Let's go ahead and combine a whole lot of things we've learned this unit into one problem to find both the maximum height of a ball that we throw through the air as well as the amount of time that ball is in the air. So we're going to combine a few different things with this problem. First thing first, we need to make sure that we're using this as our vertical motion model. So we've talked about that in class. The negative 16 comes from physics. So if you're not sure where that's coming from, don't worry about it. That's a physics question. And physics people, you may be used to using negative 9.8. That's because we're simply using different units right now. You're probably used to using meters. Our book is using feet as our unit. So here's our model. Let's go ahead and take this data, write our model, and then answer these questions using both the quadratic formula and some old things about graphing that we haven't talked about in a while. So in our model, the h over here represents the final height of the ball. In this case, we're going to catch it 3 feet off the ground. So that final height's going to be 3. Negative 16 is there, as I said, just part of physics. T is the time the ball's in the air. So that's our variable, so t squared. In our equation, v sub o represents the initial vertical velocity of the ball, so how fast we throw it initially. And I can see from the problem that that's initially thrown at a speed of 40 feet per second. And then the h sub o at the end here represents our starting height. It looks like we threw the ball in the air with an initial height of 4 feet. So there's my equation set up using the vertical motion model. The first question they asked me is how long is the ball in the air for? To answer that question, that's where I'm going to be using the quadratic formula because I want to solve for t. And so using the quadratic formula, I'm going to need to be equal to 0. So subtracting 3 from both sides, I get negative 16t squared plus 40t plus 1, because I've subtracted that 3, is now equal to 0. So using the quadratic formula, that will answer the question, how long is the ball in the air? So I'm going to skip the work for doing that. If you want to pause the video and do the quadratic formula, go for it. You may have a program on your calculator that will do that for you as well. Because we're working with a story problem, let's go ahead and round our answers, or answer, to a couple decimal places. So using the program, I've gone ahead and done that ahead of time. I came up with an answer, a time of approximately 2.525 seconds. Again, because I'm using doing a story problem, I'm okay getting a rounded answer in this case. Now, there were 2 answers I got. The other answer, though, happened to be negative, which would not make sense in this question, so I ignored that negative time. Now, the next question they asked me is, what time is the ball at its maximum height? Well, it's not necessarily half of 2.5, the time the ball's in the air for, because I didn't throw it from the same height that I caught it at. So to answer this question, remember, maximum height just refers to the vertex. So going back to the beginning of this unit, I want to go back and find the vertex of this parabola. I can do that by hand, or what I'm going to prefer to do, because I want to see the graph of this, I'm going to make a sketch of this graph. So here's what my graph will look like. I mean, it's going to be some kind of upside down parabola. What I want to do, though, is obviously do a better job than this. So let's switch over to the calculator and take a look at how we can, or review how to find the vertex. So I can answer the question, not only when is the ball at its maximum height, but what is the ball's maximum height. So this is not quadratic formula. Quadratic formula tells you how long the ball's in the air for. To find maximum height, we're still finding vertex. So let's switch over to the calculator. We've already used the quadratic formula to figure out the length of time that this ball was in the air. Let's go ahead and now use our graph to be able to find the vertex, to find the maximum height of the ball, both its maximum height and the time that it is at its maximum height. So I've already gone ahead and typed in my equation, which we came up with before, negative 16t squared. I just replaced x with t, plus 40x plus 1. So I've typed that in. If you hit graph, we probably won't see a very good graph depending on what your window is. So let's go ahead and adjust our window to something that makes a little bit more sense. So in this case, x is time. So we can't have negative time, so I'll start from 0. And we already know the maximum time the ball's in the air. It hits the ground at 2.5 seconds. So I don't need a very high maximum value. I'm just going to go to 3 seconds because I know the ball will already have landed by that point. Y then represents my maximum height. So again, I'll use 0 to represent a height on the ground. And then I really have no clue what the maximum height of this ball is. So let's maybe start with 25. I don't know. If we can't see the vertex, then we'll change that Y value. But let's start with 25. So here, there's the ball going through the air. Looks like, oops, I just missed the vertex. So don't get upset if you don't see it. Just go back and try something else. So my Y needs to be a little bit higher. It looks like the ball goes a little bit higher than 25 feet in the air. So let's just go up to 40 feet. That should be plenty because it looks like I barely missed it. So let's try a Y max of 40 and regraph it. So there's the ball going through the air. It reaches its high point. And then it lands, like we said, about 2.5 seconds later. So let's find that maximum using the calculator. Recall that it's underneath the calc menu, so hit second trace. find maximum, because we want to find a high point this time, not a low point. And they're going to ask you 3 questions. They'll say go to the left of the maximum, go to the right, and then guess. So over here, that's to the left. Just be somewhere to the left, not too close to it that you miss it. Move over somewhere to the right and press enter. And then your guess is just press enter again. So it looks like my maximum height is going to be about 2.15. Actually, that's my x value. Remember, x is time. So at what time is the ball at its maximum height? That's my x value. It's about 1.25 seconds. Almost half the time, but not quite exactly. And then the actual maximum height of the ball is the y value, which I can see is 26 feet. So make sure that you interpret those two numbers correctly and include labels with them. 1.25 seconds is when the ball's at its maximum height, and then 26 feet is the actual maximum height of the ball.